Hi everyone, my name is Justice Tsetla. Welcome to e-learning NATED Civil Engineering. Our subject today is Building and Structural Construction N6, and then the topic for today is the L-beam. So we are going to treat this question 1 here without wasting any time. Let's read. Figure 1 shows a simply supported reinforced concrete L-beam. The dead load of the L-beam is 7.5. The dead load is 7.5. And then the imposed dead load of the L-beam is 3.75 kilonewtons per meter squared. And then they gave us the span of the beam. It's 6.25. And our beam, we are going to use the stress of concrete of grade 25 concrete, and then the reinforcement is mild steel, and then they need us to calculate the suitable tension reinforcement of the beam. So now let's kickstart with our calculations. This is the FCU, the stress of concrete, which is in grade 25. The FY is the mild steel reinforcement, which is 250. The span is 6.25. So let's start by calculating the load of the beam. Under the load of the beam, we do have the design dead load and the design imposed load. So the formula for design dead load is 1.2 GN. The GN is the dead load. From the given information, the dead load of the beam is 7.5. 1.2 times 7.5 is 9. So we move to the design imposed load. For your information, the QN is the imposed load. It's 1.6 times the imposed load. From the given information, the imposed dead load of the beam is 3.75 kilonewtons per meter squared. This is our imposed load. So 1.6 times 3.75, it's 6 kilonewtons per meter. So we are going to calculate the maximum bending moment. For us to calculate the bending, here is our maximum bending moment. It's WL squared over 8. The W is the design dead load, and then the L is the span of the beam, the L beam, and then this W is the designed imposed load, and then the L is the span over 8. So let's substitute. This W is the 9. 9 is the design dead load, the calculated one, and then times 6.25. 6.25 is the length, the span. 6.25 squared plus 6 is our imposed load, this one, the calculated one, and then times the span, which is 6.25 squared, and then this is equals to 43.95 plus this is equals to 29.30, and then the maximum bending moment is 73.25 kilonewtons per meter. So now we move to the next one. We're going to calculate the value for K. K equals to bending moment of FCU, the stress of concrete, times our breadth times our effective depth, all squared. The bending moment is this one, the maximum bending moment, times 10 to the power 6. And FCU is grade 25. Use grade 25 concrete. 825 is the breadth of the L beam. 825. The 280 is the effective depth of the L beam. Remember, the effective depth is the distance from the extreme compression zone, the distance from the compression zone to the centroid of the tension reinforcement steel. This is your effective depth, which is 280. When you punch on your calculator, it's gonna give you this whole equation is gonna give you 0.045 less, this is less 0.156. Then take note, from clause 4.3.3.4.1, 4.3.4.4.3341, if K, this one is the one that we're calculating of, the answer is 0.045, and then this one is that one for 0.156. If this one is less than 0.156, then only tension reinforcement is required. Only tension reinforcement will be required. This statement simply says we are going to calculate only the tension reinforcement, and then the compression, no. Calculate the distance of the lever arm. We move to the next one. We are going to calculate the distance of the lever arm, the Z. Here is the formula for the lever arm. Z equals to D into 0.5 plus the root of 0.25 minus K over 9. This less or equals to this 0.95D. And then when we substitute this to 80, it's our effective depth. You take this one into 0.5 plus the root of 0.25, and then you take this one, not the one for that one for 0.156, and then less or equals to this, less or equals to 0.95 times the effective depth. Then the answer for this equation, when you punch on your calculator, is going to give you this 265.22 millimeters. And then this one is going to give you 0.266 millimeters, sorry. Then use the answer you got from this equation. Use 265.22 is this one. So we move to the next one. Calculate the tension reinforcements. The formula is area of steel equals to the bending moment over 0.87 times the Fy, the mild steel reinforcement, times the lever arm. 73 is the calculated maximum bending moment. 73.25 maximum bending moment, this one. Then times 10 to the power 6, 0.87 times our reinforcement is in mild steel, and then if it's in mild steel is 250, you substitute by 250, and then this one is your lever arm, this one. Your answer is 1269.82 millimeters squared. Listen carefully. This answer will lead us or will guide us to find the tension reinforcements. So we are going to the schedule. We're going to check the reinforcements on schedule A, cross-sectional area of reinforcing rods. The table, I'll show you. Ladies and gentlemen, this is our cross-sectional area of reinforcing rods, Schedule A. So this is the answer that we got when we calculate the tension reinforcements. This is the answer, 1269. Then from this table, we're looking for the number that it's bigger than this. Not too big, but the one that it's close to this number. I got 1473 under diameter 25. Let's check. 1473 and then under quantity of rods, it's 3 rods. 3 rods, 1473. It's 3 rods, diameter 25. Then the diameter of the rods for tension reinforcement is 25, and then the quantity of rods is 3. We need only 3 rods, and then the diameter of 25. So now we are going to check the maximum area of reinforcement. So for us to get this formula, it's the 4% of area of concrete. We are going to check it on clause 4.11.5.1. 4.11.5 for maximum area of reinforcement in element. We here we calculating the beam. 4.11.5.1. Lesson: neither the area of the tension reinforcement nor the area of the compression reinforcement should exceed 4% of the gross cross-sectional area of the concrete. These two, the area of tension and compression, should not exceed the 4% of the gross cross-sectional area of concrete. Compression and tension, the area should not exceed the 4% of area of gross cross-sectional area of a concrete. The 4% of that. Ladies and gentlemen, this is our gross cross-sectional area of the concrete. The length is 350, and then the breadth is 250. So we take the area, the length times the breadth. The gross cross-sectional area of a concrete, the length and the breadth of 250. So here is our formula. It's 4% of area of concrete. The area, the length is 350, the breadth is 250. Then it's 87,500, and then we need the 4% of that, which is 3,500. So this 3,500, let's go back to the clause. For tension and compression, the reinforcement should not exceed neither the 4% of gross cross-sectional area of concrete. This is our area that should not exceed the 4% of area of concrete. So it's 1473. This 1473, it's less than this number. Then the clause is correct, and then our answer is correct. Thank you. So ladies and gentlemen, we have come to the end of our lesson today. I hope you enjoyed and benefited from this lesson. For those who have questions, feel free to comment or to ask question on the comment section. And don't forget to like my page and share. And subscribe to my YouTube channel. The name of the channel is Justice Tshehla and Civil Engineering Nated e-Learning. The name of the channel is Justice Tshehla on YouTube. Thank you guys. Bye.